Today we're going to talk about kites and trapezoids. Now, we haven't really studied these shapes specifically, but you actually know way more about these shapes than you think, and they're actually pretty simple. So let's start with kites. Okay, so we learned back in chapter 1 that a kite is a quadrilateral that has two distinct pairs of consecutive congruent sides. Okay, so that means that the congruent sides are in a row. Okay, so they're next to each other. They're not opposite of each other. Okay, now that's the only thing we really talked about with kites. But what I want you to think about is, what if I were to draw in this diagonal right here? I want you to think about this figure on the top and the figure on the bottom. The figure on the top is an isosceles triangle. The figure on the bottom is an isosceles triangle. And we know quite a bit about isosceles triangles right now, right? Okay, so thinking about that again, so let me remove this diagonal for a second. When you have a kite, these angles here between the congruent sides are called the vertex angles. The other two angles are called the non-vertex angles. So if I put this diagonal back in here to think about my isosceles triangles, this is the vertex angle of an isosceles triangle. This is the vertex angle of an isosceles triangle. Okay, so that's where these names come from. All right, so look, we're going to look at properties, and I'm going to flip-flop back and forth between the properties and this figure here. So the first one says the non-vertex angles of a kite are congruent. Okay, so our non-vertex angles are going to be congruent. So we're talking about these two angles right here. These two angles are congruent, which really shouldn't be a surprise to us because the base angles of this isosceles triangle are congruent. The base angles of this isosceles triangle are congruent. So add two sets of congruent angles and they're still going to be congruent. All right, next one. The diagonals of a kite are perpendicular. All right, so let's go back. I'm going to draw in my other diagonal here. I'm going to draw in this other diagonal. And that conjecture there is saying that they are perpendicular, which again should not be a surprise, right? Because when we have an isosceles triangle, we have perpendiculars here, right? From this vertex, this can be a perpendicular. All right, now think about everything else that happens. When we talked about this yesterday, if we have an altitude, okay, so let me go back to our list and keep all that stuff from yesterday or from Monday in the back of your head. So it says the diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. So we're saying this diagonal right here is the perpendicular bisector of this diagonal, which again makes sense because we know the altitude is the median, right? Okay, so now, last one. I bet you could guess it. The vertex angles of a kite are bisected by the diagonal. So my vertex angles are bisected by the diagonal. Again, keep in mind, the altitude is the median, is the perpendicular bisector, is the angle bisector, right? So all of these properties really just came from our isosceles triangles. Okay, now I did give you this figure here. So if you want to use that to draw in all your shapes, because I have labels on the other one, we can do that. So we can show our diagonals here. We know we have these two parts here of this diagonal are congruent. We know we have a right angle. And we know the vertex angles are bisected. And we also know the non-vertex angles are congruent. Again, though, if you start thinking about it in terms of isosceles triangles, then the idea of kites become much easier. All right, the next shape we're going to talk about are trapezoids. So again, a review, a trapezoid is a quadrilateral with exactly one set of parallel sides. Okay, so exactly one pair of parallel sides. Those parallel sides are called the base. Okay, so we actually have two bases. Okay, and along the bases, we have what are called base angles. So we actually have two sets of base angles, one up here and one down here. The non-parallel sides are called the legs. So our first property here is with a trapezoid, the angles between the bases, I'm going to call this angle 1, I'm going to call this one angle 2. The angles between the bases are supplementary. So angle 1 plus angle 2 should equal 180 degrees. Okay, now this shouldn't be a surprise to you Because think about it this way. Remember we were talking about our parallel lines and we had these things called transversals, and we called this angle here and this angle here consecutive interior angles or same side interior angles, and we said they're 180 degrees. Well, that's exactly what we have right here. I just didn't draw in the other side of the trapezoid. So right here is that trapezoid we're talking about. So it all relates back to those parallel lines that we talked about a long time ago. So I can name this 3 and I could name this 4. And then angles 3 and 4 are also supplementary. And again, trying to relate back to what we've already talked about. So now I want to study a specific type of trapezoid. We also identified a trapezoid called an isosceles trapezoid. So if you remember the isosceles trapezoid, we still have the parallel bases, one set of parallel sides, but we also have congruent legs. Okay, so the legs of an isosceles trapezoid are congruent. So the conjecture we're going to talk about next is these base angles. So the base angles of an isosceles trapezoid are congruent. Okay, so those two angles down here are going to be congruent, and these two angles up here are going to be congruent. Now these two, the consecutive interiors, are still supplementary, but what's different about the isosceles is that the base angles are going to be congruent. That's not always true with other isosceles triangles. I'm sorry, other trapezoids. I'm sorry. All right, so this proof is a little bit trickier, and we're actually going to prove this in class together, I think like late next week. Okay, we're going to go through that proof because there's a lot that happens that's dealing with parallelograms and all that. So we're going to get to this proof eventually. So for right now, you just have to trust me. All right, our last conjecture, again dealing with our isosceles trapezoids. So we know that we have parallel lines. Okay, we're going to be given that we have the legs are congruent here. Okay, this conjecture says that the diagonals, so this piece right here and this piece right here, are congruent. Okay, so those pieces are congruent. So let's think about why that is. So we know if we have parallel lines, this is a transversal. So we do have sorry, we do have alternate interior angles, and we could look at, remember those, we talked about those wings. This is one of those overlapping triangle problems where we said we really had 3 sets of triangles we could look at. The wings, the trapezoids up top, I'm sorry, the triangles up top, or the triangles down below. Okay, we're going to focus on the triangles down below here. This one and this one. Now we know, because this is isosceles, we have our congruent legs. We also know that this angle is going to be congruent to this angle. And because they're overlapping, they share this side. So if I think about it like this, if I pull it apart, let me draw the other one. Okay, if I pull it apart, remember they were sharing this side here. We were given the legs are congruent, and we know that the base angles are congruent. So these two triangles are going to be congruent by side angle side. So then by CP/CTC, we know this diagonal has to be congruent to this diagonal, which happens to be this piece here. All right, so I just wanted you to take the notes today and look and read through this, or look through this video. Tomorrow in class, you're going to have an assignment just dealing with trapezoids and kites.